Good morning everyone. Myself Professor Satish Patil, Assistant Professor Mechanical Engineering Department of MIT School of Engineering in MIT Art, Design and Technology, University, Pune. Today we will go through one of the experiment of Theory of Machines 2 lab, that is to measure holding torque of epicyclic gear train. The experimental setup which we have is here. Now, objective of this experiment is to study epicyclic gear train and to measure holding torque. At the same time, we will verify that net torque in epicyclic gear train is 0. With these objectives, we can proceed further for the experimental setup. This is our experimental setup available at our lab for doing experiment on epicyclic gear train. The specifications of this setup, you can find it on this wall. Detailed specifications, you can find it on this wall, where we will get to know that in this setup there is a internal type compact epicyclic gear train. Also, we have variable speed DC motor with speed controller. In addition to this, there are digital RPM indicators with digital tachometers, where we will get to know that why we are going ahead with measuring RPM of the different shafts of epicyclic gear train. Now, in addition to that, we have rope brake arrangement to measure the external load put on the shafts of the epicyclic gear train. Now, we want to study detailed experimental setup here, wherein we will start with this control panel. So, this is the motor we have, which is of capacity 1 HP, which is capable of rotating at maximum speed of 2800 RPM. To control of this motor, we have this control panel, where we get a DC drive to vary speed of the motor, okay. And there are three different displays wherein we are going to measure voltmeter. The bottom display gives us reading of the voltage with the help of voltmeter. The middle display gives us reading of the current with the ampere meter, and the top display gives us reading of the RPM of rotating shafts of epicyclic gear train. So, with this control panel, we have epicyclic gear train, the internal type compact epicyclic gear train. If you focus on this area, this is the compact type, internal type epicyclic gear train, okay. And with this, we have input shaft on this side for this gear train and output shaft on this side, okay. Let us go into the details of epicyclic gear train first, and then we will get into details of this experimental setup and performance of this experimental setup. So, what do we have inside this gearbox, or how the gears are arranged inside this gearbox, we will get to know with this additional setup which we have. Now, I am glad to share with you that this particular setup is been fabricated by few of our third year mechanical students under their mini project activity. So, what we have exactly? So, if you look at this setup, this is the input shaft for the epicyclic gear train. This one is output shaft for the epicyclic gear train. At the same time, we have to focus on, if you just change the orientation of this gearbox, what you find, the gear arrangement, we can understand easily that on input shaft there is a central gear present. That central gear, we say it as sun gear. Now, on this sun gear, which is going to mesh with these 3 planet gears which are equally spaced around sun gear, okay. Now, this whole planet gears all planet gears as well as this sun gear assembly is in mesh with this bigger internal gear. So, this assembly is put inside this internal gear having the axis of this internal gear coinciding input shaft, or we can say intern axis of the sun gear. Okay. Now, the working of this epicyclic gear train is very interesting to know that we have sun gear to be rotated. Okay. Now, you can observe there are planet gears, 3 of these gears are rotating about their own center as well as they are rotating about the axis of sun gear. Okay. So, we have planet gears which are making rotation about their own axis, also their axis is rotating about sun gear axis. That is why the name of this gear train is epicyclic gear train. So, the advantage of this epicyclic gear train is we can get huge range of velocity ratio which could be used for different applications. Nowadays, you can find application of this epicyclic gear train in automatic transmissions. So, most of the vehicles where you find automatic transmissions, we have this kind of epicyclic gear train in those automatic transmissions. Okay. So, we will go to the how exactly it works. So, if you just start rotating input shaft in turn sun gear, the output shaft which is at the back end is connected to the axis of planets through this carrier. This plate which you are able to see at the back of this gearbox is nothing but carrier, and carrier is mounted on the output shaft. Okay. So, output speed for this gearbox epicyclic gear train is nothing but the speed of rotation of axis of this planet gears. Okay. Now, how are we going to get different range or different velocity ratios, the wide range of velocity ratios? That is interesting to know. With the help of this internal gear, we may achieve different velocity ratios. How exactly? That there could be different cases where even this internal gear could also be rotated. So, now in this arrangement, we have kept this internal gear fixed. Okay. So, with this fixed internal gear arrangement, we only able to transmit the power from input shaft to output shaft from sun gear through planet gears. Obviously, all these planet gears are also meshed with this internal gear. So, this is to note with the help of this position of internal gear and its status, whether it is rotating or stationary. Right now, in this case it is stationary. We will get different range of velocity ratios. So, you can observe one more time how exactly it works. So, if I start rotating the input shaft, the planet gears are rotating, their axis are rotating about sun gear. At the same time, if you observe, the internal gear is stationary. Okay. So, we are able to transmit power from input shaft to output shaft with the help of this epicyclic gear train. Okay. Now, this epicyclic gear train, how we have made use in the experimental setup, you check it out. Come to this main experimental setup of our today's experiment. This epicyclic arrangement is inside this gearbox. Okay. Now, for this gearbox, input shaft is here, which is connected directly to the motor. For this gearbox, input shaft which is connected to the sun gear of the epicyclic gear train. Okay. So, this input shaft is connected to the motor. So, we have the power from the motor to be transmitted from this input shaft to this output shaft. Okay. Now, there are the couple of couplings placed in between, okay, to connect motor shaft to the input shaft of the gearbox, and on other side we have also couplings to connect output shaft of the gearbox to the dynamometer on this side. Okay. So, what we need to understand here, that the power is supplied through this input shaft to the sun gear, and the carrier of the epicyclic gear train mounted on the output shaft, which is connected to this dynamometer. Whereas, we have one more rope brake dynamometer arrangement, which is here. So, you can immediately guess why exactly we need this rope brake arrangement, because as we have third component for the epicyclic gear train, obviously this rope brake arrangement is done for the third component, that is internal gear. So, the internal gear which is in this epicyclic gear train is connected to this rotating drum, okay, and their rope brake arrangement. Okay. With this, we have also the tacho generators, which will give us readings of RPM at the input shaft as well as at the output shaft. You may not be able to see right now where exactly the tacho generator is placed. So, exactly behind this coupling we have tacho generator, and on this side exactly on behind this portion there is a tacho generator. You can see here there is a screw just to get ahead with sensing pulse for every rotation of shaft, and accordingly we get measurement displayed on this display, top display. Okay. In addition to this, in this rope brake arrangement, you may see there are 4 different spring balances used, 1, 2, 3 and 4. Now, this 4 spring balance will give us readings of how much tension we are going to apply at 2 sides of the drum with the help of this rope. Okay. So, this spring balance we will get it as a W1, W2, W3 and W4. Okay. This will give us tensions on the rope at both ends of the ropes. Okay. Now, if you observe clearly, you may visualize there is a scale on spring balance on the white background, okay, whereas that scale will read how much tension we are giving to this rope at this particular end for the rope brake arrangement. Now, maximum capacity of all these particular spring balances is to have 10 kg of the tension. Okay. Now, this 10 kg, if you observe clearly, if you focus, individual mark is giving us 50 gram of the reading, whereas total spring balance at its staged capacity will give us 10 kg. Okay. So, we will going to have a reading of this spring balances based on the circular ring where exactly it is located on the scale. Accordingly, we will get to know that how much tension we are keeping on the rope brake engagement. And just to repeat, this spring balance will give us W1, this spring balance will give us W2, and at the output rope brake arrangement we have this spring balance which will give us W3, and this spring balance will give us W4. So, typically speaking, W1 and W3 are giving us tension on the tight side, and other two will give us tension on the slack side. So, this is how the experimental setup we have for today's experiment, where we will going to measure what is holding torque, and we will be observing net torque in this setup happens to be 0. Now, what exactly net torque means, okay, or what exactly holding torque means? Just before proceeding to the performance on this experimental setup, let us understand what exactly holding torque and what exactly the net torque is. Okay. So, the rope brake arrangements which we have on this side and this rope brake arrangement is on the output shaft, whereas this rope brake arrangement is to the internal gear of epicyclic gear train, where we will get to know that we are keeping this internal gear stationary. That means, in other words, we are holding this internal gear to have rotation of the internal gear to be 0. Okay. And the torque required to hold this internal gear, we are calling it as a holding torque. That is what this, as simple it is. So, holding torque holds internal gear of the epicyclic gear train, okay, and going for the net torque, okay, we are verifying that net torque in this epicyclic gear train happens to be 0. So, going for the net torque, we need to understand there is a torque on the input shaft because of the power supply from the motor, that we say it as a T1. Okay. So, we know what could be the rotation of this shaft from this display, and we know what amount of voltage and current we are supplying to the motor, and also we are taking care of the efficiency of the motor. Okay. For that, we will consider efficiency of the motor as 80%. So, with considering efficiency of the motor with known readings of voltage and current, we are able to find out what could be the torque of input shaft, that is T1. Next, we will say this holding torque as T2. So, with the help of this rope brake arrangement, with the help of the spring balances, we will be in a position to find out what is holding torque. How exactly we are going to measure? When this rope brake arrangement is utilized to measure holding torque, we will make use of what amount of radius this tensions are applied, and for that we need to know what is radius of this drum, that is 0.2 meter. Sorry, radius of the drum is 0.1 meter, okay, and radius of the rope is 0.006 meter. With this we can get what could be the effective radius where this tension is applied, and that is 0.106 meter. So, that is the effective radius, and if we know what is the value of W1 and W2, we will be in a position to find out T2, that is holding torque. Okay. So, we have T1 with us, we have T2 with us, and we will have in this end part of the setup output torque, that is T3. On similar way, we can measure T3, that is output torque. Okay. With the help of this W3 and W4 and effective radius, that is 0.106 meter, we will be in a position to find out what would be output torque, that is T3. Now, knowing T1, T2 and T3, we can get what could be the net torque. Okay. Theoretically speaking, T1 plus T2 plus T3 should be 0, but we need to know what could be the sense of T1, T2 and T3. For the understanding of that, if I put this motor on, you will get to know how exactly the shafts are rotating. Okay. I will just let us understand, we are not taking readings, but we are just checking out how exactly shafts are going to rotate. Okay. So, this is how the operating scenario for the epicyclic gear train, initial operating scenario obviously. There is little change in the operating scenario when we take readings, that I will explain now. See, we have rotation of the shaft in this direction, okay, whereas rotation of this holding drum is exactly opposite to the input shaft, and at this moment we are able to see the output drum is almost stationary. Okay. Now, we can understand that the power is getting supplied through input shaft to the sun gear of the gear train, and it is transmitted to the internal gear. So, it is not transmitted to the output shaft, it is transmitted to the internal gear, because right now the drum, holding drum is not stationary, that ultimately means internal gear is not stationary. So, power transmission is happening through sun gear to the internal gear directly. So, input shaft to internal gear directly, whereas planetary gears are rotating about their center or their axis, but their axis is not rotating about the sun gear axis. So, this is the case of simple gear train directly, where the axis of the planet gears are not rotating about the axis of sun gear. So, this is not the situation where we are taking readings for the epicyclic gear train, because it is not epicyclic gear train at all. Okay. But when we have the this holding drum, if we apply load on the holding drum, and if we make the holding drum to stop rotating in turn, it is we are keeping internal gear of this gear train stationary. So, that is where we made now this gearbox acting as a epicyclic gear train. In earlier case it was simple gear train. Now, the holding drum is stationary, that means internal gear is stationary in this gear train, that means this power from the input shaft is transmitted to the output shaft. Now, you can observe the drum on the output shaft is rotating. Okay. Now, this is where our experimental setup, or this is where this gearbox is acting as a epicyclic gear train. Okay. At this situation, we will be performing our experiment. Okay. So, we have T1 with us, T2 with us, T3 with us. Accordingly, we will get to know the net torque would be 0. For that, we need to know what is the direction of rotation of this shafts. So, input shaft, in the same sense, if you observe, this output shaft is rotating, whereas the holding torque was rotating in opposite sense. Okay. So, the sense for the torque for input is exactly in line with the rotation. So, T1 torque could be taken in this sense. If I am looking from my side, I can say this as a clockwise torque. Okay. Now, coming to the holding torque. The holding drum is rotating in opposite sense, but we are applying torque in this sense, wherein we will get to know that the holding torque applied externally is again a clockwise. Okay, because the rotating drum, holding drum was rotating in opposite sense, the torque applied is opposite to that, that is clockwise sense. So, what we have, T1 torque is in clockwise sense, T2 is in clockwise sense. Now, coming to the T3, it is rotating in clockwise sense. So, applied torque would be in opposite direction. So, it is anti-clockwise sense. So, if you put together T1 clockwise, T2 clockwise, but T3 is anti-clockwise. Accordingly, we will make use of sign convention, and then we will try to verify whether the net torque is 0 or not. Okay. Theoretically speaking, that should be 0. We will just check it out, we will verify whether it comes to 0 or closer to the 0. Okay. Thank you. Just we will have the experiment performance of epicyclic gear train to measure holding torque now. So, dear students, after learning all this experimental setup, specifications of the setup, we will proceed for the readings for this particular experiment. In this, we will take help of our lab assistant, Mr. Mahesh.
Good morning, everyone.
So, let us proceed for the readings. Just putting this experimental setup, before putting this experimental setup on, we need to ensure that the main switch on this control panel is off, so that we will put this on, and then we will make sure that every switches are in off position. Then we will put this main control switch of this control panel on. Okay. With this, we will get to know that all these displays are started, and then I will put on this DC drive switch. Now, to have this DC drive switch on, we need to ensure this DC drive knob will read 0. Okay. With this, I can put this on. Before giving speed to the motor, before giving input to the motor, we will just ensure what other things we need to make sure of for the performance. Okay. All these spring balances needs to be reading 0 in loose condition. So, how are we going to ensure that it is loose? You just observe the rope on this drum is freely moving, as like on the holding drum, it should be on output drum also. Okay. With this, we will start the experiment where we will start increasing the speed of the motor. So, here once we start taking readings, let us keep the reading here. Now, if you observe, we get some reading on the voltmeter, some reading on the ampere meter. With this, still this top display gives us 0, because we have switches here to shift between first shaft input shaft speed and output shaft speed. For that, we have switches here. So, if I put this switch on the first mode, I will get reading of the input shaft. Okay. So, with this voltage reading, current reading and RPM reading, we can come on this side, wherein we will observe, as we discussed in the explanation, initially without having external load on of output drum, we have rotation of the holding drum, that is internal gear. So, that we can take care of with the applying load on the output shaft. So, Mahesh sir, please slowly apply load on output drum. Now, while loading on the output drum, we need to ensure that we need to ensure that rotating drum is slowly rotating compared with this holding drum. Okay. Now, what we can understand, it is in simple gear train. Okay. First, we will give the load on the holding drum. So, Mahesh sir, will you please make little bit tight on this tighter side, so that the holding drum will stop rotating. Now, we have to keep on loading on this W1 spring balance unless we have rotation of this drum stop and the reading or holding drum will be stationary. In turn, we make this internal gear stationary. So, for that we need to observe, as soon as we start loading this holding drum, we get rotation in this output drum. Initially it was not rotating that fast, but right now it started rotating. Now, you can observe holding drum is totally stationary, that means internal gear is stationary and power supplied to this input shaft is directly given to the output shaft through this gearbox. So, right now we are in a case of epicyclic gear train. This is what we get into output drum. Now we can apply a little bit load on the output drum. Okay. So, we again observe the holding drum starts rotating. Okay, sir. We can also have load on this holding drum so that it will stop rotating. Now, this is the condition where we have applied torque. Okay, wait, it is already stopped. Now, this is the condition where we want to take readings, where we have kept load on the holding drum to have it stationary, and we have kept applied load on this output drum, and then we are going for noting our readings for voltage, current and RPM. Okay. So, with this we will note down what is voltage reading. Let us say it is right now 248.2 volts. Okay. The current reading 3.20 ampere. So, let us say it is 3.18 ampere. Okay. Now, we will take readings of W1, W2, W3, W4. So, if you observe in this, on this wide scale, the reading would be taken a little bit cautiously without touching spring balance. So, if I just hold it on the top, what I get right now, the reading would be around 1 kg. So, W1 for this spring balance reads 1 kg. Accordingly, we can have readings on W2, W3 and W4. Okay. With this all 4 readings with us, we can move forward for taking reading on input shaft and output shaft. So, as this knob is reading on the 1, the input shaft rotation is around 1356 RPM. So, we will note down this reading for the input shaft rotation, that is capital N1, and if I put it at neutral position and then switch this on the third position, I will get reading of rotation of output shaft. And how much is the reading for rotation of output shaft? We have it as around 270 RPM, let us say, average reading between 268 and 272, 270 RPM. So, with these readings of voltage, current and all 4 readings of the tensions on the spring balance W1, W2, W3, W4 and N1 and N2 from this RPM display, we can proceed for the calculations. What are we going to do? With these readings, we will calculate T1 with the formula given in the lab manual, or you can find it on the PPT. With this, we can find T2, that is holding torque. Okay. For that, we need to take difference between W1 and W2 and multiply it by gravitational acceleration and effective radius of the drum. And for T3, we will make use of W3 and W4 and effective radius of the drum. With this, we can measure T1, we can measure holding torque, we can measure output torque. Okay. So, while doing so, we are measuring holding torque itself, that is our first objective, measure holding torque, and second objective, to verify net torque is 0, we will make use of calculated values of T1, T2 and T3. Okay. And we will get to know that after calculation that although theoretically it should be 0, the practically we get the value close to 0. And while calculation of net torque, we will also keep in mind that the torque at the input, that is clockwise, torque at the holding drum, that is also clockwise, and torque at the output drum, that is anti-clockwise. This explanation we already discussed, why the output torque is coming anti-clockwise or in opposite sense to this holding torque and input torque. Okay. So, with this sign conventions, we will be in a position to calculate net torque is having a value close to 0. Okay. So, this is what the first set of experiment. Now, we can move forward for the second step of experiment, that is for the second readings, we need to make sure that we are starting from 0. For that, whatever applied torque we have kept it on this, if I just put for the moment the rotation of the shaft here as 0, and I will put this DC drive on off, so that you will clearly, I will be clearly audible to you. So, here we have already applied a load, here also we have already applied a load to make holding drum stationary. So, before starting second set of reading, we need to make sure that this should be loosed, this should be loosed, and again all these spring balances will read 0 value. So, once we ensure that, we can have the loosening of this spring balances, okay, which will ensure there is no applied torque on this output drum. Okay. Thank you, Mahesh sir. We can repeat it on this drum also to ensure there should not be any applied torque before starting of the second set of the reading. Okay. So, this is how we can ensure the rope is loose enough on the drum. Okay. With this, we can get ahead with the second set of experiment, and for that, for measuring the reading on the input shaft, I will put it this on 1 and I will keep this away from 3. So, I can get readings from the control panel right from initial stage. So, this is how we are going to ensure for the second set, this is loose, this is loose, all the spring balances will read 0. Okay. So, that is how the experiment needs to be performed, the readings needs to be taken with ensuring all the facts, all the things beforehand while recording the observations, while recording readings, and then we can calculate and we will get ahead with the result. Okay. So, this is how the experiments needs to be performed with its study of epicyclic gear train and measuring holding torque, and a third objective as measuring the net torque happens to be 0 in case of epicyclic gear train. So, thank you. Hope you understood all explanation and how are we going to perform on with the help of this setup for the aim of measure holding torque with the help of epicyclic gear train. Thank you. Keep learning.